There's a star in our sky that's dying, and it's closer, larger, and more unstable than any other of its kind. Astronomers are certain it will explode. The only mystery is when. Some believe it could happen tomorrow, while others think it's already gone, and we're just waiting for the light of its death to reach us. When it finally does, the explosion will be visible from Earth. But could it also shake our atmosphere or fry our satellites? The star in question is Betelgeuse, one of the most iconic yet misunderstood objects in the night sky. You've probably seen it without knowing it, glowing faintly red on Orion's shoulder. It looks calm and constant, but beneath that steady glow, it's chaotic and unstable. Its wild changes in brightness have made it one of the most watched stars in modern astronomy. Betelgeuse is a red supergiant, which means it's ancient, massive, and nearing the end of its life. But when we say massive, we're not talking about a planet-sized ball of gas. If Betelgeuse replaced our Sun, its bloated surface would reach past Mars, maybe even Jupiter. That's a monster so huge, Mercury, Venus, Earth, and Mars wouldn't just orbit it. They'd be swallowed whole, vaporized, erased. Betelgeuse is about 700 times larger than the Sun, though only around 10 to 20 times as massive. That makes it a cosmic balloon, enormous but surprisingly light for its size. A fragile giant standing at the edge of destruction, ready to make its final move across the universe. Betelgeuse is swollen from within, its outer layers stretched thin, hanging loose like a balloon on the verge of bursting. That's the danger. Once stars reach this bloated stage, their lives are measured in cosmic seconds. They burn through their remaining fuel at a furious pace, glowing red not from health, but from age and exhaustion. It's cooler than our Sun only because it's expanded so much that its surface heat has thinned out. Deep inside, the core is running on fumes, fusing heavier and heavier elements in a desperate attempt to stay alive. Hydrogen is long gone, helium too. Now it's climbing the periodic table toward iron, the point of no return. Iron is death for a star. Once fusion stops producing energy, gravity wins. The core collapses in an instant, and the result is pure violence. A supernova blast powerful enough to outshine entire galaxies. That's where Betelgeuse is heading. It's not a question of if, but when. It could happen tomorrow, or it might take another 100,000 years. At roughly 640 light-years away, even if Betelgeuse exploded right this second, its light wouldn't reach us until the year 2665. But what makes it even stranger is its heartbeat. Betelgeuse is a variable star. It pulses, brightens, and fades like it's breathing. Most red supergiants do this, but Betelgeuse does it so dramatically that we can see those changes with our bare eyes, week after week, as if it's alive and struggling to hold on. Patient sky watchers can actually follow Betelgeuse's mood swings by comparing its brightness to nearby stars like Rigel or Aldebaran. That's how the drama began. During its most recent dimming, Betelgeuse faded far more than expected. It plunged to an unusually faint level, sparking chaos in the astronomy world. Some thought it was about to explode, others blamed dust or internal shifts. Maybe it was all three, or maybe Betelgeuse was just playing tricks again. That unpredictability is exactly what makes it hypnotic. We're not just watching a star, we're witnessing a dying titan wobbling through its last breaths. Every pulse, every fade is another second on a cosmic timer counting down to its end. No one knows when the clock will hit zero. It could be in our lifetime, or long after humanity's gone. But when it does, that flash will be brighter than a full moon and visible even in daytime skies. To watch Betelgeuse is to see a slow-motion collapse unfold before our eyes, a living death happening hundreds of light-years away. The star swells, contracts, and breathes as if aware of its own fate, struggling against the inevitable. It reminds us how fragile even the mightiest objects in the universe truly are, burning, fading, and finally surrendering to the gravity that created them in the first place. In late 2019, something weird started happening. Betelgeuse began to dim, and this time it wasn't the usual slow flicker. It faded fast, losing more than half its brightness in just a few months. At first, astronomers weren't alarmed. Betelgeuse is known for mood swings. But this drop was brutal. It went from one of Orion's brightest jewels to barely cracking the top 20. Even casual stargazers could tell something was seriously off. The internet exploded with one question. Is this it? Is Betelgeuse finally about to go supernova? Even scientists didn't have a clear answer. Red supergiants don't send warnings, they just go. But this sudden, steep dimming looked like a prelude to something massive. Telescopes across the planet, and in orbit, turned toward Orion, trying to figure out what was going on. Then Hubble picked up something astonishing: a huge cloud of gas and dust drifting away from Betelgeuse. It was like the star had sneezed out part of itself. Not just a puff, but a colossal blast. One theory suggested Betelgeuse had literally blown off a chunk of its outer layers. That ejected material cooled and thickened into dust, drifting between us and the star, blocking its light and making it appear to fade. In reality, the star wasn't dying that night. It was shedding. Betelgeuse had erupted in a violent fit, losing part of its body into space, like a warning shot from a giant that knows its end is near. Betelgeuse didn't dim because it was dying. It dimmed because it covered itself. That strange darkness came from a curtain of dust it had thrown into space, blocking its own light. Some scientists think the drop in brightness might also have been caused by a sudden drop in surface temperature or turbulence deep inside the star. Red supergiants are chaotic by nature. They boil with violent convection currents that twist their shapes, create massive cool spots, and shift their brightness without warning. Maybe both theories are true. Something inside Betelgeuse snapped, triggering a violent ejection of its outer layers that then condensed into dust, shading part of the star from view. For months, the world watched in suspense. And then, just as mysteriously, Betelgeuse began to brighten again. Slowly, it returned to normal. The panic faded, but the mystery deepened. Because now we know, this star isn't just unstable, it's alive in ways we didn't expect. It can throw off a piece of itself without warning and dim by half in a matter of weeks. That realization made astronomers uneasy. If Betelgeuse can erupt like that out of nowhere, what's stopping it from crossing the final line? If a similar eruption had happened in the 1300s, we'd be seeing the light of that explosion right now. Maybe that dimming was just a random spasm. Or maybe it was the first tremor before the end. And here's the haunting part. Every time we look at Betelgeuse, we're looking 640 years into the past. Whatever's happening now has already happened. We're just waiting for the light to catch up. What we see shining in the sky tonight isn't Betelgeuse now. It's Betelgeuse from 640 years ago. That faint red light is a message sent from the 14th century, only just reaching our eyes. It's not just a poetic thought. It's a huge scientific problem, because it means we have no real-time data on this star. For all we know, Betelgeuse could have already exploded centuries ago, and we're just waiting for the light of its death to arrive. Watching it is like streaming a live event with a 640-year delay. Every flicker, every dimming, could be ancient history finally catching up. If Betelgeuse went supernova sometime around the 1380s, that flash of light would be hitting Earth right about now. And when it comes, it won't creep in quietly. It'll burst into the sky brighter than the full moon, visible even in broad daylight. It could cast shadows at night, glow for weeks or even months, and then fade into memory. But the most mind-bending part? If it happens tomorrow, it's not really happening at all. It already did, centuries ago. We'd just be witnessing the delayed echo of a long-finished cosmic event. That's why predicting Betelgeuse's explosion, is nearly impossible. Scientists can measure, model, and guess, but if the blast has already occurred, there's nothing left to predict, only to see. So they talk in terms of probabilities. Maybe tomorrow, maybe 100,000 years from now. Either way, the fuse has already been lit. We're just waiting for the light to arrive. 100,000 years might sound like forever, but in cosmic time, it's barely a blink. Stars like Betelgeuse spend millions of years shining peacefully, yet their final red supergiant phase lasts only a heartbeat. We were born at the perfect moment to witness it, or maybe just a little too late. Betelgeuse reminds us that the night sky isn't a live show. It's a gallery of ghosts. Every star is ancient light, a postcard from the past, and some of those glowing dots might already be gone. So imagine it finally happens. Betelgeuse goes supernova. What would that look like? Deep in its core, the star has been burning through heavier and heavier elements: helium, carbon, neon, oxygen, silicon, until it hits the final barrier, iron. And iron is death. Unlike lighter elements, fusing iron consumes energy instead of releasing it. When that happens, the balance breaks. The star's gravity, which has been kept at bay for millions of years, suddenly wins. The core collapses in an instant, faster than you can blink, turning into an ultra-dense sphere of iron. Then the chaos begins. The outer layers fall inward, slam into the core, and rebound outward with unthinkable force. That rebound creates a shock wave so violent it tears the entire star apart from within. A cosmic detonation that marks the end of a giant and the birth of something new. That's the moment, the explosion, the grand finale. When Betelgeuse finally goes supernova, it'll unleash a light show beyond anything humanity has ever seen. First, Earth would be silently struck by a wave of neutrinos, ghost-like particles traveling almost at light speed. They'd pass through our bodies, through the planet itself, completely unnoticed except by a few detectors buried deep underground. Then, hours later, the light would arrive. Radiation, energy, and brilliance bursting across the sky. A new star would appear out of nowhere. Except it's not a birth, it's a death. And it would shine brighter than a full moon, possibly even visible during the day. At night, it could cast shadows across the ground, glowing from Orion's shoulder like an eerie second sun. For people unaware of the science, panic would spread fast. Wild theories, fake doomsday claims, headlines screaming apocalypse. But the truth, Earth would be perfectly safe. Betelgeuse is far enough, about 640 light-years away, that the explosion's destructive power would never reach us. No deadly radiation, no shockwave, just a front-row seat to a cosmic masterpiece. The light would linger for weeks, maybe months, fading slowly as the debris cooled and drifted through space. Every telescope on Earth would be aimed at it, capturing history in motion, the exact process of a star dying before our eyes. And when the glow finally fades, something even stranger would emerge. The core that collapsed doesn't vanish, it transforms. If enough mass remains, Betelgeuse could be reborn as a neutron star, a city-sized sphere of matter so dense that a single teaspoon of it would outweigh an entire mountain. If Betelgeuse's core is heavy enough, it could collapse into a black hole, an invisible wound in space surrounded by the shattered remains of the star it once was. That's the destiny of red supergiants. They don't simply disappear, they leave scars in the universe, traces of the giants that once burned there. And when Betelgeuse finally goes, the entire world will witness it, a message from the 14th century finally catching up to us. Until then, all we can do is stare at that faint red glow and wonder, is today the day? Let's clear something up. Betelgeuse exploding will not destroy Earth. It won't melt the atmosphere, wipe out satellites, or scorch the planet. Here's why. Distance. Betelgeuse is about 640 light-years away, unimaginably far. To put it in perspective, Voyager 1, The most distant object humans have ever launched has been traveling for nearly 50 years and hasn't even made it one light day. Betelgeuse is more than 230 million times farther than that. And when it comes to supernovas, distance is everything. Yes, the explosion releases an absurd amount of energy, more in seconds than our sun will in its entire life, but that energy spreads out evenly in all directions. It's like blowing up a balloon. The farther you are from it, the thinner and weaker the blast becomes. By the time that wave of destruction reaches Earth, it'll be harmless, just a dazzling light show. People often worry about gamma rays, but even those will fade long before they ever touch us. For us, Betelgeuse's death won't be danger. It'll be one of the most breathtaking sights the human race has ever seen. People love to ask, what if Betelgeuse fires a gamma ray burst straight at Earth? It sounds terrifying. After all, gamma rays are some of the most powerful and destructive forms of radiation in the universe. At close range, one could rip apart our atmosphere, fry satellites, and wipe out life. But here's the truth. That's not going to happen. Gamma ray bursts don't spray in every direction like a bomb. They fire in narrow beams like a cosmic flashlight. And only certain collapsing stars, under precise spin conditions, even produce them. Betelgeuse doesn't fit the type. But even if by some miracle it did, the beam would need to be aimed perfectly at Earth to matter. And the odds of that are virtually zero. For a gamma ray burst to hurt us, it would have to happen within 30 light years. Betelgeuse is 20 times farther than that. It's not even close to the danger zone. So no, Betelgeuse won't cook the planet, won't burn the sky, and won't end civilization. What we'll get instead is the most spectacular, harmless light show in human history. At most, a few satellites might pick up tiny radiation spikes, or space telescopes might record bursts of high-energy particles. But those instruments are designed for far worse. The sun's own flares hit us harder, and we handle those constantly. Here on Earth, you wouldn't feel a thing. No radiation sickness, no atmospheric chaos, just a brilliant new point of light shining where Orion's shoulder used to be. The real impact won't be physical. It'll be emotional. The awe of watching a star die, knowing we're witnessing the end of a giant that's been burning since before humanity could even dream of the stars. Watching Betelgeuse explode would be unlike anything humanity has ever experienced. For weeks, maybe months, the world would look up at the same glowing spectacle, brighter than any star, visible even in daylight. It would become a shared global moment, the kind people once wrote about after seeing eclipses, comets, or the first steps on the moon. For astronomers, it would be the event of a lifetime, a real-time supernova, close enough to study in full detail. No simulations, no guesswork, just raw cosmic truth unfolding before our eyes. And the best part? We're perfectly placed for it, close enough to watch safely, far enough to survive untouched. A front-row seat to the most powerful explosion within our galactic neighborhood. So where does that leave us? We're staring at a star so massive it could swallow half our solar system, so unstable it keeps shedding pieces of itself into space, and so far away that every time we see it, we're looking 6 centuries into the past. Yet in cosmic terms, that's practically next door. When Betelgeuse finally goes, the sight will redefine how we look at the night sky. Because it's not just a star. It's a ticking time bomb made of fire and light, a countdown we can see but not hear. It might happen tomorrow. It might have already happened centuries ago. One thing's certain. When that light finally reaches us, it'll remind the entire world just how alive and unpredictable the universe really is. So keep an eye on Orion's shoulder, because one night soon, it might shine brighter than anything you've ever seen. If you enjoyed this breakdown and want to stay updated on every new space exploration, make sure to like, subscribe, and turn on notifications. Your support helps keep these deep dive updates coming. Thanks for watching, and as always, keep looking up.